Good day, my name is Philip and welcome to Chemistry Class Notes. So today we are going to be looking at electrolysis, calculations in electrolysis. Before I start this question, we are going to be using some short formulas in calculating. So we have this formula. We have this. Then we have just the IT. So we are majorly going to be using these formulas, and along the way there will be some alteration to the formula that I'm going to use. So with that in mind, let's look at this first question. Okay, let's look at this first question. It said calculate the quantity of electricity in coulombs required to liberate 10 grams of copper from a copper compound. Well, the first thing you have to write is short the half reactions, and so it's copper, so you're writing so this is a half reaction for this question. If it's jamb, of course you might not really need to write the equation. It might not be important. What you need to know is that you know that the oxidation state of copper is 2, so it's these two that are going to work with. If you are doing maybe waec, neco, and you are doing theory, you might need to show this half reaction because there are marks for it. But in jamb, you don't need it, or any objective question, you don't actually need it. What you know that once you know the oxidation state of the copper, which is 2, which is invariably you've known the number of electrons transferred, because that's what you are going to use in calculating. So we're going to just use this formula, which is Q is equals to NEF. Q is quantity of electricity, N is the amount in mole, E is the number of electrons, F is Faraday. So we have to calculate the quantity. So we have to calculate quantity. We know this 9500. Number of electrons here is 2 for copper. Then N, amount in mole. You have to calculate amount in mole, then we'll now plug into the formula to get your answer. So you know amount in mole is equals to mass over molar mass. In your question, the mass is 10. The molar mass for copper is 64. So just calculate this here, 10 over 64. So when you do this, you are getting 0.15625 mole. Then from now, since I've got the N, I can now use this equation to calculate Q. So if I substitute, that will be 0.15625 times 2 times 96500. When you do that, you should get 30156.3, because the unit is coulomb. So your answer from here, your answer is B. So number 2 question. What number of moles of Cu2 plus will be deposited by 360 coulombs of electricity So you're also going to use the same formula, which is Q is equals to NEF. Now you're looking for number of moles. You're looking for N. So I'm going to make N the subject of formula, which is Q over EF. So Q is given as 360. That's 360 over the oxidation state is 2 of copper is 2. That's 2, which is E, number of electrons transferred. Then times 96500. So when you do this, you should get 0.001865. So to put it in standard form, that will be 1, 2, 3. That is 1.87 times 10 to the power minus 3. So your answer. So your answer is B also. So number 3. You're looking for mass. So you're going to use this formula. M equals to Q times RAM over EF. So we are looking for the mass. We're only given time and current. But we know that we know this. We are given what to calculate for Q. You know that Q is equals to IT. Our current is 10. Our time is 4830 seconds. So I'll first of all calculate Q, then put it into this equation so that we can get the mass. So I'll say Q equals to 10 times 4830. You're going to get you're going to get 4830, 0. So I'm going to put it into this equation so that I can calculate my M. So M will now be 48300 times the relative atomic mass of silver is 108 over the oxidation state of silver is 1, which is the mole of electron transferred is 1. So I'm going to say 1 times 96500 is 1. So when you do this, you should get 54.005 gram. So the answer would be 54.05. Here, they calculate the volume in cm cube of oxygen evaporated by STP when the current of 5A is passed through 75 water for 193 seconds. So we're given the molar volume of gas at STP as 22.4. For this question, the molar volume of gas, we will need that formula. So you know that amount in mole is equals to the molar volume of gas over 22.4. So what we need to do from this equation, we have to first of all calculate, since we are looking for the molar volume of gas, we have to calculate the amount in mole so that we can use this equation to calculate the molar volume of gas. Remember, electrolysis of acidified water, the half reaction for that is this 4H minus 2H2O plus O2 plus 4E electron. So this is the mole of electron transferred. So you are working with this 4. So we're going to make use of that other equation, which is Q equals to NEF. Then N is equals to Q over EF. I know that Q is equals to IT, current times time. That is 5 times, time is 190 over E, mode of electron transferred, 4. And 96500. So when you do this out, you should get 0.0025 cosmol. So we calculate N. I'm going to put this N here so I can find molar volume of gas. So that I can find the volume, the volume of the gas, Vn, volume of gas. So I'm going to say 0.0025 equals to V over 22.4. So V will now be equals to 22.4 times 0.0025. So everything you should get 0.056 dm cube. So the answer will be A. How many parallel parasitic is required to produce 0.25 mole of copper? Alright, we'll first write the half reaction. So yeah, you know that one mole of this copper is equivalent to this, which is 2 Faraday. You go like this, 1 mole of copper is equivalent to this 2F. For this kind of equation, that's how you solve it. 1 mole of the element is equivalent to 2F, 2 Faraday. This 2 is this 2. So from here, we are giving 0.25 mole. So I'm going to put 0.25 mole under here. Why? Because this is mole, this is mole. Then I'm going to call here X. Of course, this is in column. This side is in column. So for me, I'm going to cross multiply. So when I do that, I'll make S sort of formula. S will now be equal to 2F times 0.25 mole over 1 mole. So of course, mole will cancel mole. 2F times 0.25, you will get 0.5 Faraday, which is D. Remember how I started? I said 1 mole of copper, from what you are seeing here, is equivalent to 2 Faraday. There are different ways people might solve it. People might have another way, but follow this way. Then I bring this mole we are given in question under here. I'll make here X. Then you cross multiply. End of the day, you cancel this, you get 0.5. That will be your answer. The quantity of resistivity liberates 0.6 gram of silver from its salt. What mass of aluminium will be liberated from its salt by the same quantity of electricity? So this one, we are solving for two things: silver and aluminium. But for silver, we are giving 3.6 grams of silver. We know that one, and we know the atomic mass of silver. But for aluminium, we only know the atomic mass of aluminium. But for silver, we know both the atomic mass and the mass. But they said the quantity of electricity liberates this. They say you should find the mass of the aluminium that is liberated from the salt by the same quantity of electricity. Meaning, I will calculate the quantity of electricity for silver. Then from that, I will use that quantity to calculate the mass for aluminium, because they said from what mass of aluminium will be liberated from its salt by the same quantity of electricity. So I'm going to go like this. Q equals to NEF. Remember, this one is for silver. Silver is, oxidation state is 1. So yeah, this E, number of electron transfer, will be 1 for silver. Ag plus. That's what we are using. My aluminium is Al3 plus. Aluminium will be 3. Silver will be 1. Alright, then we'll use let's use this formula. M equals to Q times RAM over EF. So we know the mass. We know this. So we are calculating for the quantity of electricity. I just make Q sort of formula. Q will now be MEF over RAM. M is 3.6, E is 1, F is 9500, RAM for silver, atomic mass is 108. So Q equals to 3.6 times 1 times 96500 over 108 is equal to, that should be 3.2 and 6. Okay. That's 3, 2, 1, 6.666. Okay. So this is the quantity of electricity. So from here, I'm going to use the same formula, but in this case, I'm going to be looking for M for aluminium. I'm going to use the same formula now, but I'm going to calculate the mass for aluminium. So I'm going to say M is equals to Q times RAM over EF. Remember, I've calculated the quantity of electricity here, so I just put it in. So I'm looking for the mass of aluminium. M equals to 3216.666. The atomic mass of aluminium is 27. The mole of electron for aluminium is 3 times 96500. When you do that, you should get 0.3 gram. What mass of copper will be liberated will be produced by caloric reduction of CO2 plus when 1.6 ampere of current passes through a solution of CSO4 for 1 hour. So remember, the time is in seconds. If you are giving time in hour, you also multiply by 3600. That is 60 times 60, so that you convert to seconds. If you are giving time in minutes, multiply by 60 to convert to seconds. But if you are giving time in hours, multiply by 600. So we have to calculate the mass. So we are still going to use this formula. M equals to Q times RAM over EF. So we know this. Then this Q equals to IT. Q equals to IT. So I is 1.60. Then T is 1 times 60 times 60 is 1 times 3600. So when you do that, you should get 5760 seconds. So you have converted the time from hour to seconds. So this is the time we're going to use. This is the quantity of electricity now you're going to use. Put here so that you can calculate your mass. So I'm going to put it now, which is 5760 times the relative atomic mass of copper, 64, over E. Copper is, the original state of copper is 2. 2 times 96500. So you should get 1.19 cost gram. The answer is C. This would have to be liberated with 0.125 of oxygen molecules during a trace of the sodium chloride solution is. So I'm going to call it. Remember, I'm going to talk about the content that will liberate 0.25 mole of oxygen molecules during electrolysis. You should remember the half reaction of oxygen. So you're going to use 4. The mole direction that is transferred is 4. Have that in mind. So we're just going to use this equation. Q equals to NEF. F is 96500, E is 4, then N 0.125 mole. So just put in the information. 1.25 times E is 4 times 96500. So when you calculate that, you should get 48250 C. That should be C. What mass of magnesium would be obtained by passing current of 2 ampere for 2 hours 30 minutes through molten magnesium chloride? Remember, magnesium state is +2, so you are working with 2. Don't forget. So we are looking at calculating the mass. So we're going to use this formula. But we're not giving Q. Instead, we're giving time and current. So we're going to calculate for time and current for equals to IT. That means, remember, the time is in 2 hours 30 minutes, meaning I'm going to convert both of them to seconds. I'm going to do it like this: 2 times 3600 plus 30 times 60. Multiply this one, add it together. That's how you convert it to seconds. 2 hours 30 minutes. So I'm going to say 2 times This is 2 times 3,600 plus 30 times 60. So what it means is that this times this, what you get, you add it to this times this, then before you now multiply by 2. It's not hard. 2 times 3,600, get your answer, multiply 30, get your answer, add them together. You add them together. That's what you do. 9,000 coulomb. When you do everything here, you should get 9,000 coulomb. I'm going to put this Q here, which is M equals to 9,000 times M, then E 2 times 96500. So now you should get that is 1.12 gram. So A is your answer. Question: which of the following ions require the largest quantity of electricity for discharge at an electrode? A. 2 mole of Q3 plus, 2.5 mole of RO 2 plus, 0.0 mole of T minus, then 4.0 mole of Y minus. Alright, the thing is that we're just going to use this formula, Q equals to NEF. Look at the first one. N is 2, E is 3, F 96500. Let's do it together. So 2 times 3 times 96500. You should get 579000. I'll go to B. 2.5 times 2 times 96500. I should get 482,500. See, 3 times this minus, of course, minus 1 is 1 times 96500. I should get 289,500. Then the last one, 4 times minus 1, that is 1 times 96500. I should get 8,000. So for me, that requires the largest quantity of electricity from what you have calculated is the first one. You can see it, 579000 is decreasing. In fact, Faraday's second law, is saying that when the same quantity of electricity is passed through solutions of different electrolytes, the relative number of moles of electron discharge is inversely proportional to the on the ion. So you notice that as the amount of the mole substance is decreasing, as the mole is decreasing, the quantity discharge, as the mole substance is increasing, the quantity discharge is decreasing. There's an inverse relationship. So your answer, from what you have seen now, your answer is A, because 579000 is higher than the rest. Okay, this question: how long will it take to deposit 0.08 gram of copper from CaO2 solution by passing a current of 0.5 ampere? Alright, so you're looking for time, but remember, the time here now is in minutes. Take note. So we're going to use this formula, M equals to Q times ROAM over EF. So we know, we're going to, okay, then we're also going to use Q equals to IT. That means we make Q through a formula, we'll find Q, Then we'll put it here so that we can find time by making time instead of the formula. So let's first of all find Q. So Q is now equals to MEF over RAN. M is 0.08. E, copper is Cu2 plus, charge of plus 2, so that's 2. Then times 96500. The atomic mass of copper is 64. So when you do this, you should get 241.25. So that's the quantity of electricity. So I'm gonna, since we've gotten Q, I want to now put it here so that I can find the time. So time T equals to Q over I, which is 241.25 over current is 0.5. So when you do that, you should get as 482.5. So this is the time. But remember, we're given the options. The time is in minutes. To convert to minutes, you divide by 60. To convert to hours, you divide by 3600. So since we are converting to minutes, I'll just divide by 60. When you do that, you get 8.0 something, approximately 8 minutes. So your answer is B. Remember, to convert from seconds to minutes, you divide by 60, but from seconds to hours, you divide by 3600. Why to convert back, you are doing the opposite. To convert from minutes to seconds, you multiply by 60. To convert from hours to seconds, you multiply by 3600. So that is the end of the video. This video will be beneficial for people writing various exams from waec, neco, GC, jamb, on electrolysis. Until next time, where I'll put out another video, But one other thing, I would like to chip this in. If maybe you feel you want to encourage me, it's not by force. If you want to encourage me, I will leave maybe my bank details in the description below. Anything, you can just put in something for me, just to encourage me to continue to put out more of these videos. So bye.